Hello, good day. Thanks for joining me. This is the Adobe Fikemba theory. In this channel, I told I'll be teaching you physics, chemistry, biology, and then we just finished biology. So we're going to be looking at chemistry. And in chemistry, we've been dealing with separation techniques, as the case may be. And now, just go and watch chemistry part 1, part 2, part 3. It'll tell you how we started with other separation techniques. Now we're going to be looking at another separation techniques. So we're going to be learning chemistry now, and we're going to be looking at, we'll continue from where we stopped, talking about separation techniques. So this is chemistry, okay, and then we have separation techniques, okay, that's what we've been discussing. And then in this separation technique, we're going to be looking at distillation. Okay, distillation. Now, what is distillation? This is a type of separation technique where the liquid part of a mixture is recovered. Okay, it is used to recover a solvent from a solution. Okay, it is used to recover a solvent from a solution. That's number one. Let me put that there so you get that. Okay, distillation is used to recover solvent from a what? Solution. That's number one. Distillation can also be used, okay, to purify a liquid that contains non-volatile impurity. So we can use distillation to do what? To purify a liquid. Okay, to purify a liquid that contains what? Non-volatile impurities. Okay, please just help me with the writing. Don't purify a liquid non-volatile, but I've said what I wanted to say in. So just understand what I'm trying to say. So number one, it can be used to recover solvent from a solution. And number two, it can be used to purify a liquid that contains, so this side is that contains non-volatile impurity. So when we talk about something is non-volatile, it means when that kind of thing is exposed, it does not catch fire. So when you say non-volatile, is not flammable, as the case may be, it doesn't catch fire when exposed. Number three, you also want to look at what this distillation can be used for. Distillation can also be used to separate two or more mixable liquids, okay? Two mixable liquids that has a large difference in their boiling point. So it can be used to separate mixable liquids, okay? It's used to separate what? Mixable liquids with large difference in their boiling point. I will give you an example. With what? With large difference in their what? Boiling point. So understand what I'm doing now. So I've already stated it. Just ignore if I didn't write it completely. So it is used, number one, to recover solvent from a solution, purify a liquid that contains non-volatile impurities, okay? So since it's non-volatile, it cannot catch fire. Then three, mixable liquid, it is also used to separate two mixable liquids with large difference in their boiling point. I will give you an example. An example is the separation between alcohol and water, or let's say ethanol and water. So example is the separation of ethanol and water. Can you see that now? One ethanol will boil at a temperature of 78 degrees Celsius. Water will boil at 100 degrees Celsius. So the implication is that you have a distillation flask where heat is applied. Okay. Now the liquid with the lower boiling point will distill first. Okay. It will vaporize. When it vaporizes, then it goes straight to a condenser we call Liebig, okay, Liebig condenser. So you go through the Liebig condenser, which is saturated with what? Cold water. Now, when it goes to the Liebig condenser, there it will now do what? It will now condense. It will now do what? Liquefy. What's liquefaction? The coming together of gaseous molecule to form liquid or water. So, as the case may be now, as you heat this now, what happens is that the ethanol, because it has low boiling point as compared to the water, will do what? Will vaporize first, getting straight moving straight down to the light B condenser that will now condense it and finally give what we call, form a substance which we call distillate. Distillate. Okay? This distillate will now be collected as ethanol in this other angle, while the water will remain. So with this method, you've been able to separate ethanol and water. Do you understand what distillation is all about now? Okay, so take note of the point I raised. It is used to recover solvent from a solution, purify a liquid that contains non-volatile impurities, and is also used to separate miscible liquids with large difference in their boiling point. And in doing that, you heat the liquid in a distillating flask, and then you condense the one that vaporizes out first, and then a distillate is formed. Number two, we want to look at fractional distillation. Fractional distillation. Okay, so when we talk about fractional distillation is like distillation too. It has similar setup, but there's a slight difference. Now, in fractional distillation, it is used to separate mixable liquids, two or more mixable liquids, okay, with close boiling points. Are you seeing it now? Two or more mixable liquids with what? With close boiling points. And then for effective fractional distillation, the difference in the boiling point between this among this liquid must be greater than 10 degrees Celsius. So number one, it is used to separate two or more liquids with what? Take note, close boiling points. That's number one. Then number two, for effective fractional distillation, the boiling point between or amongst these liquids to be separated must be greater. Must be what? Must be what? Greater than 10 degrees Celsius. Okay? It's greater than fine. Must be greater than 10 degrees Celsius. Now, another thing you need to understand about fractional distillation is that fractional distillation, what makes it different a little bit from distillation is what? The presence of a fractionating column. What I say, you write fractionating column. You see it now? So there's no difference between this and this. It's the same method. But in this case, in fractional distillation, the fractionating column is the region where the actual separation takes place. Now, the fractionating column is made up of glass beads. Okay? It's made up of what? Glass beads. Here, this is the upper part of the layer of the fractionating column, and this is the lower part of the fractionating column. Now, this upper part has low temperature. Okay? And this side is made up of what? High temperature. High temperature. This is because directly around this region, you have where the heat is coming. As it's going out. Now, I want you to know something. As it is vaporizing, okay, liquids that have a low boiling point will do what? Will first of all leave out of the what? The distillating flask into the fractionating column first. Do you understand what I'm saying now? So the one with the lowest boiling point will first of all lead out into the fractionating column, and then they'll start leaving and separation will start taking place inside this place. Now, this kind of separation technique method is predominantly used in the petroleum industry. It's petroleum industry. It is used to separate the constituent of crude oil. So this method is predominantly used in the what? In the petroleum industry. Predominantly used here, petroleum industry, to separate what? Constituent of what? Crude oil. And you know, this crude oil, from this petroleum industry, you can get natural gas. Okay, just follow me. Natural gas. This video might be long, but just bear it. You understand? I don't want to explain them in an isolated form. I want them to be together. So that's why just bear. Natural gas. You can also have what we call kerosene. Okay, the kerosene you use for cooking. You have petrol running your cars. Okay, you understand? You don't have bitumen. Okay, so you can see that now. So this fractional distillation, number one, you must know that it has what? It is used to separate different liquids with close boiling points. And for effective fractional distillation, their boiling point must be what? Greater than 10 degrees Celsius. Also, you must know that there is a presence of what? A fractionating column. And number four, I also stated that the liquids with the lowest boiling point, liquids with the what? Lowest boiling point, I'll just put BP as boiling point, will what? Vaporize first. leaving the distillating flask, going straight into the where? Into the fractionating column where the actual separation takes place. And then from there, they can move to the Leibniz condenser, and then they will now condense separately as the case may be. So that is this thing, fractionating column gives the major difference of this. So this separation technique can be carried out in petroleum industry to separate what? To separate crude oil, constituent of crude oil into natural gas, kerosene, petrol, as the case may be. It can also be used again to separate benzene. Take note, fractional distillation is best used to separate benzene and methyl benzene. Methyl benzene. I think this methyl benzene should be toluene. Okay, that's the name. Okay, that's the name. Okay, let me write it so that you can see. It can be used, fractional distillation can be used to separate what? Benzene. Look at this now. It can be used to separate benzene and methyl benzene. Another name for this methyl benzene is called what? Toluene. Okay? Toluene. Are you seeing it now? So fractional distillation is used to separate these ones. Benzene and methylbenzene. This is another example, so that you don't think it's only for petroleum industry, but this is predominantly used for that. Also, it can also be used to separate the mixture of air, okay, to their various components as noble gas. That's number 3. I've given you 3 examples. So another example is separation of the constituent of air. Air is a mixture. I hope you know that. Air. In air, you can have noble gas. Okay? You can get noble gas. What else? Nitrogen. You can see nitrogen. What other component do you have? Oxygen. Okay? Other component again you have carbon dioxide. Okay? And that's it, etc. So with fractional distillation, you can be able to separate the constituent of air and also separate the what? The mixture between methylbenzene and benzene. Methylbenzene is toluene. And lastly, it can be used in the petroleum industry to separate what? To separate the constituent of crude oil. Okay, let me spell the constituents. For those of us that would like the spelling, see it at the upper part of this board. Constituent. Okay, constituent means what it contains, the various forms in that mixture. Okay, that's what it is of crude oil. I'd like you to follow me if you have not followed me. I tell you, I'm very determined to make you get A1 in this subject. Just follow me. Okay, share the video. Thank you. See you in the next video.